Question 8 is about acids and alkalis. Now this question is about titration, but before they ask you any questions related to titration, the first part is about how pH of an acid is related to the strength and the concentration. So these are the two factors that we will have to focus on. So we can talk about strength, and we can say when it comes to strength, it determines the ability to dissociate in solution. So I can say if strength increases, dissociation will increase. So the acid will dissociate more. Next factor is about the concentration. Now the concentration determines the amount of acid. Amount of acid in solvent. So in this case, I can say if concentration increases, then amount will increase. When I combine these two factors, they will tell us about the amount of H plus. So if strength increases, H plus will be higher in amount because it will completely dissociate. If concentration increases, then the H plus will again increase. So I can say here greater strength and higher concentration means the concentration of H plus will be high. Of H plus will be very high. If it is high, therefore I can say pH will be low. Next part says a student titrated 25 centimeter cube of hydrochloric acid with 0.100 mole dm³ barium hydroxide solution. Now this statement is very important because it is telling us that there are two chemicals. What are those two chemicals? One is hydrochloric acid and the other one is barium hydroxide. When it comes to hydrochloric acid, we've been given the volume of it because it says 25 centimeter cube of hydrochloric acid. So the volume is 25 centimeter cube. When it comes to the barium hydroxide, we've been given the concentration of barium hydroxide, which is, I can say concentration is equal to 0.100 mole per dm³. This means in 1 dm³, which is same as 1 liter of the solution, you'll find 0.100 moles of barium hydroxide. Then it tells us a little bit about the experiment. It says they did 5 titrations, and out of these 5 titrations, they worked out the volume of barium hydroxide solution was this, right? So for the first titration, they required 23.90 centimeter cube of barium hydroxide. Then you can see the constant. Then you can see the volume required has been reduced. Now it says the student calculated the volume of barium hydroxide solution to be used in the titration calculations as 23.50 centimeter cube. Now remember, this is my mean volume. And the mean volume is always based on the results which are concordant to each other. Here it says explain why the student used a volume of 23.50 of barium hydroxide solution in the titration calculation. So all you have to say is these 4 values are within plus minus 0.10 centimeter cube of each other. Therefore, they are concordant. And the mean of these 4 values is equal to 23.50 centimeter cube. But this value here is my rough titration. Therefore, it is not concordant with other volumes. So we can't use it because it's too far away from the other four values. You can see the difference between them four is plus minus 0.10. So from here, what we have got now is we've got the volume of barium hydroxide, and I can write that value of volume as 23.50 centimeter cube. Next part says 25 centimeter cube of hydrochloric acid reacted with 23.50 centimeter cube of 0.100 mole dm cube barium hydroxide solution. So I've converted this information into a table, and the table is here. It says the equation for the reaction is this. This is very, very important equation because you'll have to use this equation to determine the moles of the missing chemical. It says calculate the concentration of hydrochloric acid in mole dm cube. So step one is always you will convert concentration in volume, which is given to you, into moles. So in this case, it is about barium hydroxide. So I'm going to say moles of BaOH whole 2 is equal to C times V over 1,000. All I need to do is I need to plug in the values for C and V. I do know the value of concentration, which is 0.1. I do know the value of volume, which is 23.50 over 1,000. And if you put these in your calculator, you'll end up with a value of 0.00235. These are the moles of barium hydroxide. Step 2 is always based on equation. So my equation tells me that 2 moles of hydrochloric acid react with 1 mole of barium hydroxide. So whatever the amount of barium hydroxide is, you will have double the amount of hydrochloric acid. So we know that the barium hydroxide is this much. So I can say for step 2, using equation, I can say moles of HCl in 25 centimeter cube will be 2 times 0.00235. If you put it in your calculator, you will end up with a value which will be 0.00470. Now for step 3, I will use the same equation that I used for step 1. Moles equal C times V over 1,000. But this time I will be doing this calculation for the hydrochloric acid. So I do know the value of moles, which is 0.00470. I don't know the value of concentration, but I do know the value of the volume. If you look here, I wrote it for you, 25 centimeter cube of hydrochloric acid over 1,000. And you need to solve this to work out the answer. To simplify it, what I'm going to do is I'm going to put 1 in the denominator and I'll cross multiply them. And when you do that, you'll end up with 0.00470 times by 1,000 equals C times 25. We divide both sides by 25. This cancels out. On the right side, you have only C. On the left side, if you plug this in your calculator and solve, you'll end up with a value of 0.188. It'll be mole per dm. And that's my answer. The question continues and it says another student titrated sulfuric acid with barium hydroxide solution. The equation for the reaction is shown. 1 mole of sulfuric acid reacts with 1 mole of barium hydroxide to produce 1 mole of barium sulfate and 2 moles of liquid water. Now you have to pay attention to this. This time it is solid. Now it says the student measured the electrical conductivity of mixture using the titration. So this time the electrical conductivity will depend on the concentration of ions, right? And these ions have to be free. They should be able to move within the solution. The better a conductor, the higher the electrical conductivity. Now they've given us some information and they say when the volume of barium hydroxide solution added in centimeter cube is 30, the electrical conductivity is basically 0. So it's explained why the electrical conductivity of the mixture was 0 when the sulfuric acid had just been neutralized. What does this mean? This means H2SO4 moles are equal to BaOH O2 moles. Okay, when this is the case, then they will neutralize. Because I'm saying this because they both react in 1:1 mole ratio. So let's use the equation for the react. So based on the equation, I can say BaSO4 solid is produced. Number 1. Okay. Number 2, I'm gonna say H plus and OH minus. They react to produce H2O liquid. So in this case, this is solid, this is liquid, there are no ions. So I can then say, therefore, no ions are available / free to move and carry charge. Next part says the student then added a further 10 centimeter cube of barium hydroxide solution. So when you add further 10 centimeter cube of barium hydroxide solution, it's an ionic compound. This means you now have Ba2 positive and OH minus ions because it's in excess. The electrical conductivity of the mixture increased. Give one reason. We can now say barium and OH minus ions are free to move and carry